Hello, hi, good morning. Okay. Uh, in the previous few videos, we discussed about misconceptions in physics. A few of the viewers suggested that, see, usually concepts are being taught in books. Misconceptions, you have taken some examples and described it. But what is a misconcept according to you may not be a misconcept for a student. So, how do we realize it? So, this was a bigger question. I thought that's also a good one. But how do we address that what is bad for you is good for me, or good for me is bad for you? This is something which was troubling me. And one of the viewers, she suggested me, so instead of doing like this, so what you can do is look for concepts and explain us when a particular concept should not be used. Wow, that really strike the bullseye. So I thought, okay, that's also a good one. Okay, usually what we have learned is when to apply a concept. Now let us do something on when not to apply a concept. Okay. So towards it, so I thought let us try as a trial and error basis with something on tension and its calculations. And part of it will be related to circular motion also. Usually it is circular motion. And I observe that many of the students do commit a mistake in these subjects or in these concepts. Okay. So because it appears that situations will be similar, not identical. But still they think that the concepts can also be same concepts can be also be applied here, which is incorrect. Okay, so let us try with this. Okay, the first one towards this exercise is that I'm going to try with tension is not equal in connected bodies. Right, as you see here, you have an object connected with a string here, and as a result of this, the tension here can be directly written as tension equal to weight, which is equal to mg. Very clear. Now let us take up this example. So in this example, you see there's a tension T1, there's a tension T2 here. These are all known as connected bodies. It doesn't matter whether this is 2 kg, 3 kg, 5 kg, or once again 2 kg, 2 kg, and 2 kg. Okay, whatever you take, you will be able to see to it that the tensions would be different. Okay, what is tension? Tension is nothing but pulling force. Pulling force. Okay. Now how do I calculate the tension here? The way how we calculate in this case is that the shortcut. I'll go with the shortcut method. Okay, for this situation. So I have 2 kg, 3 kg, 5 kg. These strings do not have any mass. The total mass here is 5 plus 3, 8 plus 2, 10. Total mass here is 10 kg. And you see there is a one force, 10 Newton is applying on this. And as a result of it, all these objects are going with the same direction with the same acceleration. So if you ask me what is the net acceleration, I can only say apply Newton's second law. And we know that F equal to m into A. F is nothing but applied force, 10 Newton. This should be equal to mass. What is mass? 10 kg multiplied by A. It is as if saying that this one system. Instead of putting two strings over here, I could have said that this 2, 3, and 5 kg, I will shorten the string's length. Okay, I'll put a hook in between. I'll put one hook here. I'll put another hook over here. And I'm going to join this. Okay, when I'm going to join this, definitely you can say all of them are moving at the same acceleration. And hence you see the acceleration A would be equal to 1 meter per second square. Simple. Okay. Now, next what we do is, let us consider the free body diagrams. The free body diagram for this one would be, let me write this. Since it is going in the forward direction, I can now say 10 minus T1 is equal to 2A. And as a result of this, I'll put A equal to 1 here. This means I'll write 10 minus T1 is equal to 2. This implies T1 should be equal to 10 minus 2, which is 8 Newton. So 8 Newton. If 8 Newton is acting over here, what should be the rest of them? Let us look at this also if you want. Now I can now write T1 for the test. So the second object, I can write T1 minus T2 is equal to 3, right? And thus I can write T1 is equal to T2 plus 3, which should be, what is T2? T2 is, sorry, what is T2? Do I need T2? I need to get the value of T2. I'm sorry. I need to get the value of T2. T2 should be equal to T1 minus 3. I can write like this. What is T1? T1 we already got 8. minus what is 3 multiplied by A? What is A? 1. Which should just be equal to 2 Newton, right? This is one way of solving it. But the easiest way to solve it across it is, if you are applying a force of 10 Newton, this 10 Newton should get distributed in this object and this object. Simple. If this is 8 Newton, this should be 2 Newton. Okay, logic. Most of the physics problems, you can solve it without using math. Okay, if you use math, it's boring. If you use a logic like this, it becomes more easier. Okay, so 2 Newton is the force over here. Now you observe that T1 and T2 are not one and the same. Okay. By the same lines, if you say, if the objects were 2, 2, 2 each, now what do you say? This is 10 Newton over here. If there were 2 kgs, okay, let me solve that also. This is 2 kgs. This once again 2 kg. This once again 2 kg. Okay, one of the student asked me this. Sir, if you change this value, what will happen? If you make it all of them to be identical, then what will happen? Will the tension remain the same? And he believed that it should be the same. Okay, let us look at this also. We are applying a force of 10 Newton. Now, what is the acceleration? Now, what do we do is, we replace these strings with hooks. Put one hook here, another hook here. So, therefore, now these are joined. So, 2 plus 2 plus 2, 4, 4 plus 2, 6. So, A should be equal to net force, which is 10 Newton divided by net mass, which is 6, which should be equal to 5 by 3. Okay, I'm not going to substitute. The simplify this, meter per second square. I'll just keep it like this. Now, towards it, what is the tension acting on the, what is the tension here? So, let us draw the free body diagram for this one. So 10 minus T1 should be equal to 2 into 5 by 3, which should be equal to 10 by 3, right? So your 10 T1 should now be equal to 10 minus 10 by 3, 10 minus 10 by 3, which should be equal to 20 by 3 Newton. Okay. So therefore, if this is 21 Newton, now what do we have? We should have T1 plus T2 should be equal to 10 Newton, right? So T2 should be equal to 10 minus 20 by 3, which should once again be equal to 10 by 3 Newton. Simple. Okay, so now you see here it is 20 by 3 Newton, here it is 10 by 3 Newton, right? So therefore, so tensions need not be the same, right? Now let us look at, so therefore now you have, I hope you would have understood that tensions need not be the same when the bodies, and there is a string which is connected between any two objects. Okay, so therefore, tension here throughout, from here to here, it will be the same if it's a light string. Okay, but if it is a hard string, if it's a hard, if it is a hard string, which means that if it is something like a rod, okay, if this also has a mass, tension will differ. That we will consider in the next lecture. But currently, let us look at only this here. Okay, so therefore, so here you see this tension would be different from this tension. Now, same thing also applies here. So here people won't make mistake because many of the textbooks have these kinds of problems. Blindly, they would have solved it, and you would also consider the same thing. Now let us look at this problem. The cursor, right? I'll keep it here. Right. Now here what happens? Now you have let me assume that. So in this case, the pulley is assumed to be massless. So if that is the case, the tension here and tension here will remain the same, which everyone has done it. What is this example? The example here is Atwood's mission. Atwood's mission. Right? You would have heard this. And the tension was given by the formula 2 times M1, M2, G divided by M1 plus M2. Right? Very easy to solve. Let us take up this example. This example, you see, let me consider this as mass M, this is mass M, this is mass M. Now, which direction will these objects move? See, this is 2m here, this is m here. Definitely it moves with this acceleration A. Okay. So now, if that is the case, let us write down the free body diagram for each one of them. Now, for the object C, now this is M, this is mg, this is tension, what do you call this as? Let me call this as tension Tc. So I will be writing this as mg minus Tc is equal to ma. Now for the object B, I don't have space. I'll do it right now over here itself. For the object B, now this object has been pulled by this, which is the mg. The weight of it object acts like this, and there's already a tension force acting here. The tension force here, what did we call this as? This Tc. Okay, if this object is pulled like this object is also pulled downwards. So this is your Tc, and this would be your Tb. And thus, what do we have here? The object is moving downwards. Thus, we can now say Tc plus mg minus Tb is equal to ma. Okay, we have got the second equation. Let us look at this equation. So here what do we have? This object has been pulled in this way. So therefore this is TA and mg is acting downwards here. So what do I have here? The object is moving upwards. So I can now write, I can take this direction as positive, and thus I can write TA minus mg is equal to ma. Right? Now we have three equations here. First equation, second equation, third equation. Now we need to solve. Now how do we solve? Add up. सब कुछ add करो. So mg minus tc plus tc, this 2 goes away, plus mg. So mg plus mg becomes 2mg minus tb plus ta. My God, this is ta here. This ta is equal to tb here, right? So I'll write this as tb itself. tb minus mg. So therefore, if you want, I can write like this: mj plus mg minus mg, right? This should now be equal to mg. This should be equal to, on the right hand side, what do we have? ma plus ma plus ma, 3ma. What I did was I just added all of them. Okay. So therefore, I should be getting the answer as a equal to g divided by 3. A equal to g by 3. Now, if I get this, now calculating tension is not very difficult. How do you calculate tension? So which tension I want? I want this tension. Okay. So Tc should now be equal to mg minus ma. See, I am pulling this one here. I am pushing this one outside. Minus mg by 3. I have substituted the value of a in this expression, and thus I got mg by 3 here. When it comes inside, it becomes mg minus mg by 3, which should now be equal to 2mg by 3, right? Then what about tb? See, from this equation I can get tb. So what is tb here? This implies tb is equal to mg plus ma. What is mg plus ma? mg, are kahan gaye bhai? mg plus ma. What is ma? mg by 3. mg by 3. Oh my God, what is this? mg by 3. Okay. So which should now be equal to 4mg by 3. Now I have got an expression for TB also. See, for an expression for TB, I have got here. Expression for TC, I have got here. Okay. Now, just a moment. Okay. So what do I need? I needed only the value of. So I'll write it over here because I don't have space. Now I can say that TB was equal to 4mg divided by 3. 4mg divided by 3, and Tc is equal to 2mg divided by 3. What is Tb here? This was your Tb. Tb or Ta was equal to 4mg by 3. So this was more, right? 4mg by 3, and this is 2mg by 3. How did you understand? See, though in this pulley system we took the tension to be same, because only between two objects there was a string current. Now you see there are three objects, two strings are needed. So tension will not be the same. Okay. So this is what it is. In other words, if it's like something like, okay, you have one object connected to this. Let us say, for example, I take up this mouse. I hope you are able to see this. Okay. If you look at this mouse, I am holding it with a card. The tension here could be equal to the weight. Now, if I add something else here, then what will happen? The tension will be much larger. I need to pull a larger force over here, right? So this is what it means. The tension will not be equal between any two connected bodies. I hope you like this video. In the next video, we'll see more about, okay, so how you should not use a particular concept. Okay, thus you can see tension is constant. That concept could be used only for a single object. But you should not use that concept when, if you have something like many connected objects like this, and tensions will not be the same for every connected object here. Okay, it could be something here, it could be something here, it could be something here, and so on. Okay, so if you like my video, so do like, share, comment, and whatever you need about it, and do subscribe to my channel so that it gives me an appreciation to do more and more videos. Thank you.